In this video, we will compare the relationship between symmetry and chirality, as well as the concept of mesocompounds. To get started, let's consider the following molecule. Draw these two chlorines right here. And we want to find its enantiomer. You should notice that there are chiral centers in this molecule, respectively here and here, because both of these carbon atoms here are attached to 4 different groups. So the easy way, as you know, of writing the enantiomer is just to switch the wedges to dashes and vice versa. So I'll draw the pentane ring, cyclopentane, and I'll switch both of these wedges to dashes. In other cases, we should expect that we have an enantiomer here, but we don't. This isn't an enantiomer, because let's consider if we were to rotate the molecule along an axis like this and rotate it this way so that we have those dashes facing towards us. The result would be this, which you should notice is the exact same thing as this molecule we started with. These types of molecules that have chiral centers but they don't have an enantiomer or a twin are called mesocompounds. And another way, an easy way to identify them is to find a line of reflectional symmetry or a plane of symmetry, which if we were to go back to the molecule we began with, that would be right down here, because both of these groups are on wedges, and essentially this molecule reflects perfectly along this symmetry that we've drawn. Sometimes it can be slightly difficult to determine if a molecule has a plane of symmetry. Let's take this molecule for example. We have cyclohexane, we have this iodine atom on the wedge, and another iodine atom on the dash. Now, you can see that if we tried to do a horizontal line of symmetry, that these two iodines wouldn't match up because one's going up and one's going down, or one's on the wedge and one's on the dash. But what if we were to set the plane of symmetry directly down the middle of these iodine atoms in the middle of the molecule, like so? That would be a line of symmetry because these atoms, in a way, if you want to think about it, are cut in half. And that would make this a mesocompound because if I try to take the enantiomer, or try to draw the enantiomer, I'll do the same process as usual. Switch the wedges and dashes. Well, if I just spin the molecule around this way, I would get the same exact molecule that I see on the right. They're the same compound, and this makes this a mesocompound. So, to recap, a molecule that has a plane of symmetry will be a chiral, and these compounds that we refer to as mesocompounds are compounds that when you try to find their twin, their enantiomer, that it doesn't exist because it's the same compound. There is no difference. It's the same person. So you'll want to be on the lookout for mesocompounds and, in general, compounds that might look different but are actually the same when you're doing a test, doing practice problems, whatever you might find. So keep this in your mind as you work through stereochemistry.